Yes, I'd like to thank everybody for taking time out of their morning, afternoon, evening, night, wherever you may be from, to attend today's webinar on three-dimensional fires. My name is Jeff Bonkoski. I've been with Hazard Control Technologies since 2012 after I had retired from the fire service. I was in a small department up in Michigan where I had trained to the level of a hazmat specialist. I was a paramedic. And then basically throughout my career, learned as much as I could about hazardous materials and some of the high hazard fires that firefighters are faced with on a daily basis. And I was hoping after retiring to take some time and do consulting. And I started with the ethanol industry because of the fact that it was becoming the #1 commodity shipped by rail. And in trying to find better ways to deal with those types of fires, my research led me to hazardous control technologies and all of the benefits that I hope to kind of share with you through this program that is going to deal with three-dimensional fires, which is the biggest reason why I made recommendations that many industries convert from what they're currently using to this. And hopefully through this presentation, I can share some of the things that I've learned through the time. As I said, with hazard control technologies, we kind of have the same ideologies of trying to make the world a safer place with not only leadership and fire prevention, but protection, suppression. And we're trying to do it with eco-friendly and innovative technology, which we're going to learn as we go along. We're based out of Atlanta, Georgia. We have a global distribution around the world. We're worldwide. And we've been around doing consulting and training since 1997. So we're not just a startup company. We're recognized and we're parts of or represented throughout many organizations. We're an ISO 9001 company, which we're very proud of. Quality control is very important, making sure that we get our clients and our customers the best that we can. We're members of the NFPA. We have people that sit on technical committees and help with standards. And there's some good things that are going to be coming out in these standards, and we're looking forward to doing and having more in effect, even more standards. And we're ISTA contributors, so we're currently in the fire training, the fire brigade training manual, and hopefully soon to be in the next edition of the ISTA fire training manual. And we do trainings with the Society of Fire Protection Engineers. So we try to get out and educate people as much as we can on encapsulator technologies and all the things that we have an effect on, which are lithium ion batteries. While we hear that there's no solution, it's, copious amounts of water. If you sat in on our lithium ion battery webinar, you'll see that, the effects that an encapsulator agent can have on these types of batteries. But what we're going to really key in today is going to be three-dimensional fires. We also have effects on your Class D metals and solar panels. So there's many applications. So when we sit there and start looking and thinking about these three-dimensional fire solutions, okay, some of the things that we want to touch base on is like the chemistry of fire, the encapsulator. What is an encapsulator? Hopefully we'll get that answered for you, the features of an encapsulator agent, some of the applications, and mostly today we're going to be discussing that three-dimensional application. So I'm hoping through this presentation to kind of explain the differences between water, foam, and encapsulator agent, and give you a better understanding and an explanation of just exactly what an encapsulator agent is and how it does in the different industries that we have an effect on. Now, very, very long ago, when I first started in the fire service, I'm kind of dating myself, but we used to have a fire triangle. And through the years, we found out, oh, hey, there's one other aspect, and it became the fire tetrahedron. I got a real quick video just to help explain that tetrahedron a little bit.
The representation of a fire triangle has been replaced with a fire tetrahedron. The because we now know and recognize a fourth element crucial to combustion, a chemical chain reaction. The four sides of a tetrahedron represent the four components of fire: heat, fuel, oxidizing agent, and the chemical chain reaction. If any one or more of these components are absent, a fire cannot occur. When all four components are present, heat, fuel, oxidizing agent, and the chemical chain reaction, fire will occur. There are four options for extinguishment: cut off oxygen, cut off fuel supply, thermal insulation of the fuel, and interruption of the chemical chain reaction. When one or more of the components are removed, the flame goes out.
Okay, so currently when we're sitting there and we're fighting fires and we're looking at this fire tetrahedron, many times fire departments are using water. We're using water, we're converting it to steam and trying to help use that steam to smother fires. It's really not a very effective way of trying to put out a fire. I mean, we're using millions and millions of gallons of water on some of our commercial structures and hundreds of thousands of gallons probably on some of our even residential fires. So water is, it's like 3 to 5% effective at being able to cool and extinguish. And when water doesn't work, we sit there and we start looking at our foams, Class A foam for, Class A fire and our Class B foams. And we're trying to smother the fire with these foams and cause the blanket. But again, it's what do we do when we're cold? We grab a blanket, we put it on. Well, we're doing pretty much the same thing when we use a foam blanket. We're not dissipating, we're not getting rid of the heat. So we're actually, once that blanket breaks down, and that heat source is exposed to air again or oxygen, we have a rekindle, we have a reignition. So it's kind of again, not a really great source or a choice. And the last one that we have to look at is, Class B fires. Class B fires, we're only getting a two-dimensional capability out of those types of foam. So again, very ineffective, especially if we were dealing with the three-dimensional fires that we're going to be talking about. So when we look at an encapsulator agent, things we're going to learn today is how we're able to rapid and permanently reduce the heat. With hydrocarbons and polar solvents, we're able to render them non-flammable, and that interruption of the free radical coalescence that we see, that fourth leg of the triangle or the tetrahedron. And we're going to talk how these are encapsulator agents work on the three-dimensional fires. So as I said, when we sit there and we start looking at some of the agents that we talk about, one was water. Well, one of the additives we can add to it is covered under NFPA 18, which is a water agent or a wetting agent. It makes water droplets smaller to help them get into pores or smaller areas, reduces that surface tension. It works the same mechanism. Water converts water to steam. When we look at foam, again, thin wall bubble structures, very fragile. We have to be careful, especially with Class B fires, that we don't interrupt or walk through these blankets and disturb them, because the properties or the effects we're trying to accomplish are going to be reduced by walking through. It's going to allow flammable vapors to escape, and if they find a source of ignition, there's going to be a reapplication time. And we've found out from a recent incident that, that reapplication time, because of the heat of the day, the temperatures, may be quite often. And then we're going to sit there and we're going to talk today with the encapsulator agents that fall under NFPA 18A and how they're able to reduce that surface tension. We're able to encapsulate not only fuels, but vapors. And I often ask the question when I do some of these trainings, can anybody name me another fire suppression agent out there that can suppress vapors, possibly preventing a fire? We'll see some of that in some of our other programs, but I'll talk a little today. And then that rapid change in heat, how we're able to drop temperatures 10 to 20 times faster. what's one of the main causes of reignitions when we deal with many of our flammable vapor or our flammable gas fires? We have hot steel. We have that reignition potential. So if we can cool that metal, that steel, we're greatly reducing that reignition. So we'll see how we're able to rapidly drop those temperatures. And then the interruption of the free radical coalescence, how we're able to deal with those. But first off, when we sit there, we start talking about foams. And we talk about, their ability to work on a two-dimensional fire, that pool fire. It's basically covered in the NFPA 11 foam standard. If you look in Annex A11 of the foam standard, it states foam is not suitable for a three-dimensional flowing liquid fuel fire or for gas fires. And, gas fires like LNG, LPG, and different types of gases. As I said, it's right here in the standard even states that those are not suitable. So we'll talk the difference about how encapsulator agents can have that effect on those. So to start with, let's learn a little bit about what an encapsulator agent is. So back in 1996, we acquired the patent rights for this water additive with superior cooling effects, and we find that it's very effective on pretty much all classes of fires. We're finding out with current testing going on with HCT Europe and Johnson Controls and others that, we have a great effect on being able to extinguish and stop thermal runaway in lithium-ion batteries. We work on those pressurized three-dimensional fires. So it's an agent that works on all these classes of fires. And while we seem to have, I guess in the fire service that history of not wanting to adopt change, here we have an agent that can help us in dealing with all of these types of fires. And now it's a problem. I shouldn't say a problem, but a matter of us getting out and hopefully getting people educated on how this agent works much differently than all the others that we're used to. When we look at it in the standard, there is a section, and it's covered in section 7.7 of the NFPA 18A, and it's called a spherical micelle stability test. And if we think about foam, when we look at, our different classes of foam, we have foam tests. And what we're doing is we're checking and we're testing the stability of a bubble, a thin wall bubble structure, and being able to suppress vapors. Well, we're not making bubbles. We're chemically changing the makeup of a water droplet. And in so doing, we're making spherical micelles. And real quick, what is a building block of our water or an encapsulator agent? The building block of an encapsulator agent is these spherical micelles. Okay, that chemical change of a water droplet and how it's able to affect not only our hydrocarbons, but we're able to deal with both polar and non-polar. And again, I bring up that vapor molecule. So when we sit there and start looking,
encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient the non-polar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The non-polar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So it's really important to understand how we get into the water.
Encapsulator tech.
Sorry about that. So as that video showed, there's millions and millions of micelles inside of each and every water droplet and give you just an idea of how many of those micelles are inside of a droplet. If a water droplet was the size of the earth, okay, those micelles inside would be about the size of a pea. And that's where we're going to sit there and we're going to have an understanding of how these micelles work and being able to encapsulate your hydrocarbons, your polar solvents. And once they get encapsulated inside of the water droplet, how they're able to render them non-flammable, non-ignitable. So first, we're going to sit there and we're going to start talking about our unique features, the rapid cooling. We'll talk more about the encapsulation, the toxin reduction, because it's important to understand how that encapsulation and how those micelles work. So we will explain that more. Your toxin reduction. And when we talk about the toxin reduction, as you watch some of the videos where we're showing encapsulator agents being used, watch black smoke turning white. And again, it's 100% fluorine free. So we'll be talking more about that as well. So when we look at how encapsulator agents are able to reduce these high temperatures, okay, this is a real quick video that helps to explain it. When we sit there and we look at this video, we've got a person that has a blowtorch. He's heating this steel up to 1200 degrees with an acetylene torch. And unfortunately, the thermal imagery that they're using stops at reading temperatures at like that 1230 degree mark, 38 degree mark. It doesn't read much higher than that. But as you can see from the bright, glowing red, and not only that, but the paint on the hood starting to burn, you can see that, we have a really, really hot spot going on this particular hood. One of the things I want to point out as he starts spraying is you see this white mist coming off there. He's barehanded. There's no steam. It's not steam that he's creating because of the characteristics of how micelles and those water droplets work. But he's been able to take, within a matter of seconds, using a very small amount of encapsulator agent, F500, and he's been able to cool that from excess of 1230 degrees down to less than 100 degrees, where he's able to put his hand on it. So I mentioned again, when we sit there and we start looking at, these reignition sources, if you're dealing with some type of a three-dimensional fire, dealing with flammable gases or liquids, the metal structure is just a source of reignition. So the next thing we want to hopefully discuss and help you understand a little better is the encapsulation. How is it able to encapsulate fuels and render them so that they can't be relit? And in order to understand that, there is a formula. Their formula is 1 part of F500 encapsulator agent, 8 parts of fuel, and 40 parts of water minimum, plus kinetic energy. So it's 1-to-5 ratio. And we'll see here, we talked, and in a slide just a few minutes ago, I mentioned in NFPA 18A, the 7.7 spherical micelle stability test. Here it is. And to give you a better understanding, the way this test works,
We're demonstrating the NFPA section 7.7 spherical micelle stability test. In that test, you take your test fuel, in this case gasoline, it could be ethane, alcohol, ethanol, and we're pouring in 1 gallon of the fuel into the test pan. 16 ounces of the encapsulator agent being tested. A calibrated 5-gallon per minute nozzle. We're going to add 5 gallons into this mixture. So basically, we're going to add water for 1 minute. Mix it around and agitate the mixture all around.
This test is testing the ability of an agent to develop and maintain stable spherical micelles in the presence of high heat. In the water for a total of 1 minute, which will represent 5 gallons. On the test balls for 1 minute, and then we come by and we will apply a heat source to the top of the surface of this mixture. We don't have any ignition. After 1 minute, we can see we have a heat here. We apply this to the top surface of the mixture, go all around. We shouldn't see any flammability. Demonstrate that we have a torch. We're evaporating water off the pavement. And now we'll come back after 2 hours and redo the ignition test. And after 2 hours, this cannot ignite. Thus, it proves that we have created stable spherical micelles and they remain stable over a long period of time in the presence of high heat. Because we have a blanket, 2 hours later, all the bubbles would have dissipated, and you could end up with ignition after 2 hours. What this test is showing you is this agent creates, forms, and maintains stable spherical micelles that can encapsulate the fuel, thus separating the fuel from the oxygen, and those micelles are stable at a very high heat environment.
So that is the 7-7 test that all the is part of the QA/QC of an encapsulator agent F500 encapsulator agent. And it shows you how it's able to neutralize those fuels and render them non-ignitable. Once they've been encapsulated, you can basically use that torch and evaporate that solution, that encapsulated gasoline solution or ethanol solution, whatever the fuel source may be. You can basically evaporate that entire solution away, and at no time will you have a reignition. So the next thing we want to talk about is the ability of an encapsulator agent to have an effect on that, free radical, the coalescence, how our black smoke is turning white and how it's able to reduce toxins and soot. And this comes from a test that was done by Clemson University. They were using a fuel source, which was toluene, and they built an inverted funnel. And they were looking at 3 things. They were looking at light transmission through the smoke column, the buildup of soot, and then the toxicity of the soot. And they used water as one source, and then they were using a 3% mixture of F500 encapsulator agent. And when they did the test, they found out that when they used Encapsulator Agent F500, they were able to increase the visibility through the smoke column by 68%. That buildup of soot on the sides of the inverted funnel was reduced by 97%, but the toxicity, the toxins were reduced by 98.6%. So when we sit there and we start looking at cancer in the fire service and our exposures to these toxins, some of these industrial fires. I mean, let's think about this. I mean, here is an agent that can help to reduce our exposure to these carcinogens and these toxins. And we're fluorine free. We're going to talk a lot about this fluorine free and some things as we go through, because PFOS and the PFOAs, it's being more and more publicized. Many states and countries are coming down and becoming more strict and trying to reduce. And we're going to see just how big of a problem this is when we sit there and we start looking at, again, our use of Class B foams on three-dimensional fires, which they're not suited to be able to put out as the NFPA standard stated. So when we look at F500 encapsulator agent, the advantages, well, it's non-corrosive, it's non-hazardous, it's fluorine-free. In fact, it's been tested to the EPA modified 537 test, testing 4 fluorinated ingredients, and there were none detectable of the 25 that were tested for. And it's 100% biodegradable. It doesn't stay in the environment. We're on the EPA's National Contingency Plan and listed as a surface washing agent. So when we sit there, we start looking at foams. The problem with the foams are those forever chemicals, as we are starting to call them, the PFOS and the PFOAs, and all of the different reports and the concerns. This is starting in 2009, but it started well before this. But many of these countries are starting to ban the production of any new products that have PFOS based products in them. And 3M was one that basically blew the whistle on themselves back in 2002. But in the published reports, we're finding out that firefighters are greatly affected because of the forever chemicals, the foams that are in there. And we have to start looking at, these fluorinated surfactants in our bloodstreams. And here was an example. The United States paid out, millions of dollars for treatment of a water treatment system for residents that were downstream. Australia. So this isn't just a problem here, and this is around the world. Here we have Australia that's talking about their environmental protection and water sources. Again, we have an Air Force base in 2017. Defense and New Zealand, the minister with the PFOS and the PFOAs. The higher than acceptable levels. So when we sit there and start looking at this, I mean, what is, I guess you can say, a acceptable level? And Hernan is going through. So I mean, there's hyperlinks on these articles. Feel free, please, to look some of these up. But these are some really good. But when we sit there and we start looking at the military, they and I shouldn't say and pick on the military, because we have many areas of the country where we even have airports. Our airport and our vehicles of training has to take place. It's regulated, where they have to, on an annual basis, do training. So in the past, they've been going out with their fluorinated foams and doing these trainings, leading to multi-billion-dollar cleanups. And this is just a real quick, again, some data that was shown in covering the United States, and it shows some of the areas, some of the highest affected areas of the country where these are known to be. And again, with firefighters, once the Navy came and developed these foams, they were taken on also by the fire service as a way to be able to deal with some of the difficult fires that we're being faced with. So we sit there, we go through and we start looking at all of these different articles, these people coming out and trying to remove these foams from their countries and trying to get these out of the environment. You know, while they've been around for many, many years, and we've talked about it being a forever chemical and how it's affected firefighters. Well, you know, when we sit there and start looking at all of these different areas around the airports and so on and so forth, one of the things I want to point out is here's one again in the United States, Cannon Air Force Base by a dairy farm. Right now, currently, 12 to 15,000 gallons of milk a day need to be disposed of because of the contaminated drinking water. Well, for how many years did those cows, or how many years before the PFOS and the PFOAs were detected, how many gallons of milk went to market where people were drinking? Okay. And again, it's bioaccumulative. Okay. So once it gets into our system, basically we're maintaining it. And while many in our trade magazines talk about cancer, there's many, many, many more health effects that have been found to be caused by exposures and being exposed to or getting these chemicals into our systems. So, you know, it's not just air bases, it's not just airports, it's not just firefighting, but it's all the other areas. It gets into waterways, it gets into fish. We've got air bases, we got, you know, where there's a 5-mile radius around the air base, do not eat deer. So the effects to all of us because of these chemicals is worldwide, and it's everywhere. We really need to have more I guess awareness of what we're exposed to on a daily basis. So as I go through again and talking about the applications, we're going to start getting a little bit more into that three-dimensional side of things. But you know, we're dealing with all of the different classes of fires that we're able to work on. Your lithium-ion batteries, when we sit there and we start and we hear in many cases that, you know, encapsulator agents, or I should say, lithium-ion batteries are difficult to put out. Well, we go through this. This is an introduction video to an encapsulator agent. And one of the things you're going to see is it works on all classes of fires. We have all the classes of fires. Again, when we look, black smoke turning quickly to white, the rapid extinguishment of a three-dimensional tire fire. It's not a lot of fires. Here's an example of a car fire using what we call our turbo knockdown nozzle, our TKO nozzle. It's a 20 gallon per minute nozzle, but look how little water that's being used and how little effect it's having to the environment on the ground. When we talk about foams have 3 application techniques: rain it down, bank it in, roll it on. As you see in these videos with Class B fires, there's no special application technique. We saw in the NFPA 18 Annex A11, foam's not suitable for three-dimensional fire, but yet an encapsulator agent in just a few seconds is able to very quickly extinguish it. Now, again, how about that flammable gas that foams weren't able to? Our Class C energized batteries. And one of the things I point out is he's using short little dispersants of the agent. He's not using a constant spray. Your Class D metals. Okay, no explosion because it's not truly water that's coming in contact with that Class D metal. It's that spherical micelle that's put that cocoon around that water droplet. Now, how about energized areas? This is actually a transformer that's failed. It may be in an energized environment, but it has failed. There's no longer arcing and sparking. So it's able to work on a Class B fire in a Class C environment. So let's talk a little bit more and get into that three-dimensional. They're undetermined low boil, all the different areas that we can be utilized in power companies and transformers. tank farms, pipelines. I know, in doing some reading on some of these different tank farm fires that have occurred, it could have been something as small as, and I'm going to say as small as a manifold. The problem is foam doesn't work on the three-dimensional aspects of a manifold fire. But we just saw that jet engine cowling being extinguished with an F500 encapsulator agent in seconds. So if an F500 encapsulator agent was available and used on a manifold fire in a tank farm, it could have prevented some large tank farm fires. So it's a huge benefit. And when I sit there and I'm starting to show these videos, these firefighters are not doing anything wrong. Okay, the problem is they're using foam, which is designed for a two-dimensional fire on a three-dimensional fire. And when we sit there, we start looking at, if there's, a hole or a leak, where water can get into that tank, what's it going to do? It's going to cause that gas in the tank to be displaced and spread out. Foam, we'll get into our different expansion and different types of nozzles to help aerate and create thicker blankets. Again, we're dealing with a three-dimensional fire. So while foam eventually may be able to extinguish a fire like this, look at the contamination being caused. Look at the area where all of that foam is being spread across the surface of the ground, getting into sewers, getting into groundwater systems. Foam again. Here we have a three-dimensional fire. So as we sit there and we start using foam and we start adding more, what's the fuel going to do? It's going to start floating on the surface. So now what may have been a small fire inside of a plant or inside of a facility, we sit there and we start using our foam, and next thing you know, we have all of that fuel burning up, and there goes a $1 million piece of equipment that the firefighters use. One of the other methods that we're going to see when we look at, and applications are used many times with the ARF vehicles, and it's a dual agent. In order to be able to extinguish these three-dimensional fires, they're using foam to work on the two-dimensional aspects and trying to create a blanket. And as you can see, the application, he's trying to rain it down and get that footprint built and trying to get it extinguished, building up enough foam on there to smother that fire out. But if there's a three-dimensional aspect to the fire, it can make it very, very difficult. So what they will do is, you'll see here in a second, you're going to have a gentleman come in and he's going to have a dry chemical, and he's going to try to assist in using the powder to help in extinguishing this fire. And that's the same technique that if we watch videos from some fires where jet engines or aircraft may be involved, jet fuel may be involved, they're going to be using dual agents and trying to suppress those types of fires. Yet, we just saw with that video of the jet engine cowling and some of those other videos, how effective an encapsulator agent is, being able to cool the steel, okay, and being able to extinguish the fire. Another example, we have, a couple of different nozzles going on, a couple of different agents going on this particular three-dimensional fire. And, look at the difficulties that they are having in trying to extinguish, even though they're using these dual agents. But yet now we're going to sit there and we're going to go and let's look at the effectiveness of an encapsulator agent and how quickly we can extinguish some of the same types of fires. Here's a distillation column. Okay, seconds. Here's like a well blow-off valve. Again, we're not using big water, one hand line. Instead of 4 or 5 trying to put out, we're using one hand line. Okay, look at the effect and how quickly they're able to deal with that three-dimensional fire. While we have seen this one, a mock-up of a jet engine cowling, 27 seconds. He's able to work, and he's doing two things. He's working not only to encapsulate the fuel and being able to extinguish that fuel, he's also cooling the steel. And watch, he gets his fire out, and that jet fuel is still flowing. So it's not that the fuel was shut off so he could put it out. He was able to put that out with the jet fuel still flowing. I talked about the manifold. Okay, here's again, just one hand line. We're not using dual agents and multiple hand lines, multiple master streams. I mean, we have one hand line and we'll be able to deal with these types of fires. LP gas. Now, how quickly. Some of our different types of tanks. Again, that manifold. And while he continues to flow the F500, he'll continue to encapsulate that flammable gas while he's able to then reach in and shut the valve off, possibly stopping any further gas from getting out. When we look at some of the other, but here we have, again, an example at a refinery, some testing. This is a three-dimensional inclined plank where they're using diesel fuel. So where the foam standard talks about not being able to extinguish this type of a fire because it has a three-dimensional aspect to it, this is, again, we're looking at the need for that dry powder to assist in being able to extinguish. And you're going to see, again, some of the technique that's being used as they sit there and they start using an encapsulator agent, 500, 125 gallon per minute nozzle, just one single nozzle. We're not using multiple lines, but again, he's working on doing two things. He's working on encapsulating the fuel and the vapors and cooling the steel, which is a reignition source. And as you notice, as he sits there and starts cooling off and he starts extinguishing the plank, he then sweeps down and starts hitting the pool, which is that reignition source after he cools the steel. So he gets in there and he starts getting on an angle where he can get all of it at one time. He cools that plank, he cools it down. Now he quickly starts sweeping around and he puts that fire out in 35 seconds. But yet, how many hand lines did we see where they were using water and purple K or some other type of a dry powder, 3-4 lines, and they were having difficulties in trying to put out that column, that distillation column. So this was some testing or some work that was done and I'm going to turn that off. But it's showing the difference, between foam and encapsulator agent. When they're sitting there and they're hitting the fire, as you can see, they're starting to hit the fire before it really gets a chance to get burning really, really well. They're keeping it cool and trying to keep it somewhat under control. If you look at the side with the encapsulator agent, they've kind of let that grow and get pretty good size. But yet when they sit there and they start attacking it with the encapsulator agent, look at how quickly they're able to extinguish that three-dimensional fire. Two hand lines, same as the other. Within seconds, with the F500, they've been able to extinguish that tank fire. Now, like I say, they've got the hose lines trying to keep it cool and trying to keep the fire small so that as they come in with the foam, hopefully they can extinguish it. And as you can see, the difficulties that they're having. Let's refer back to that Annex A11. Okay, foam is not suitable for being able to extinguish this type of a fire. Even though they kept it smaller than the one that they put out with the F500, they are still having a difficult time. And as you can see, towards the bottom of that tank truck, that stream of gasoline that's just lit and flowing into that pan that's underneath. They can't put that stream out. You know, they might be able to disturb it, as you can see, but they can't put it out. So that's a huge difference when we sit there and we start looking at foam versus your encapsulator agent. You know, here we have a turbo cannon. Sorry, that was designed and used by the Italian Navy, but we have other different types of applications and different response trailers where this can be utilized from with different types of monitors, configurations. But we want to talk about, you know, concentrate control systems, how we can protect our loading racks, how we can storage areas, our manifolds that I talked about and valves, some of the different delivery systems for the cannon, and we've got the trailers and compressed air systems. But some of the things that we want to talk about as well is the three-dimensional aspect, that vapor encapsulation explosion protection system. How about if we have a gas being released into the atmosphere? With the monitoring that we have, we can detect those flammable vapors, and this VEEP system can activate and basically prevent fires and explosions from happening. So as like a little summary, and we've talked about all the different unique features of an encapsulator agent, how it encapsulates hydrocarbons and polar solvents, different types of fuel, the unmatched ability for the heat reduction, the cancer-causing carcinogens, and how it works on those three-dimensional as well as two-dimensional fire. And when we sit there, we look at some of the equipment that we can be used with, you know, current sprinkler systems. If you have a fire protection system and you want to improve its capabilities, yes, we can help out with systems that can be put in our concentrate control system. As you can see again, the video off to the right is the VEEP system. But we've got concentrate control systems, and we've got water-driven proportioners, which are down on the bottom left, which can be used to protect transformers, manifolds, under turbine lube oil systems. The uses are endless as far as trying to help protect your facility or different types of facilities. Some of our other systems, we have our carts, our QAMUs, our quick attack mobile units. And again, one of these carts, one of these trailers, and I want to brag about this particular trailer on the bottom. This is a trailer that was recently used, a matter of response at an airport where there was estimated to be 3,700 gallons of jet fuel spilled. And I mentioned earlier about the foam and the heat of the day and having that have an effect on the foam. Well, at this airport, it did just that. What happened was the heat of the day was causing the foam to break down, or what we call runoff. And in the process thereof, they had to reapply the mil-spec Class B foam every 6 to 7 minutes. They used a total of about 12 to 1,500 gallons of mil-spec, which is probably some of the highest PFOA foams concentrates available. Anyway, they used about 12 to 1,500 gallons of that concentrate to try to keep the vapor suppressed. And they had a couple of issues that they were of concern. Is one was a pump house, which they were afraid would be a source of ignition. And the second was the control tower for this particular airport was only like 280 yards away from where this huge jet fuel spill occurred. So they called for this trailer, which a local utility makes available to the fire departments that service them. And so this trailer was called for, and it holds 500 gallons of F500 concentrate. And they used, what I'm told is all 400 or all 500 gallons. And they encapsulated all the gasoline after they sprayed the entire area that was affected. They gave about 20 to 30 minutes for the encapsulator agent to work. And then they brought out their multi-gas monitoring and they walked through the area and they were reading 0 LEL. So the incident commander on scene deemed the area safe and allowed all the responders to go home. They figured, hey, we'll wait till tomorrow and we'll have a cleanup contractor, environmental cleanup contractor come in and we'll have them mitigate and finish the cleanup. Well, the following morning, the cleanup contractor arrived on scene and basically he found nothing to clean up. He just for testing purpose, I guess you can say, or just to see if he could really find anything. They dug up a couple of spots. In one spot, they dug about 1.5 inches of dirt, and another spot, they took maybe a 1/2 inch. They were on site for about an hour to an hour and a half, I'm told, and they deemed that scene was mitigated and clean. So here, instead of having to dig up and spend days and days and days removing soil and replacing soil, that scene was mitigated with 500 gallons using 3,700 gallons of jet fuel. So when we sit there, we start looking, because an encapsulator agent is different than foam. One of the things that we want to make sure we do is that we make sure we do our consulting and make sure we offer the training so that it's used correctly and that it's not wasted. And that's what came in with that scene at that airport where it was used. I had done training with a fire department that also covers that particular airport. So they were well aware of how to use and apply F500 so that it would be that effective. So those consultant services, emergency response planning, if you do have systems, the concentrate testing and certification, we offer dust hazard analysis. As far as training courses, we're getting into some of our electric vehicles or our hybrid vehicles and some of these others. So we can offer training with modern day car fire, solar panels, lithium ion battery hazards that may be within your community, in your area, and emergency response training. So I hope I showed and explained the differences and how water and foam and encapsulator agents are different, and how an encapsulator agent works on all classes of fire very effectively. In most cases, especially with your class B types of fires, there's no special techniques like with foam where it's rain it down, bank it in, or roll it on. Here you can aggressively attack the fire. There's no need for dual agents. So with that, I'm going to open up and see if anybody has questions, and let's get them answered for you here.
This is for the people. Has the product been tested to the Australian standards?
I'm sorry, what was that? Product been tested to Australian standards?
I believe Graham has to answer the question. Has the product been tested to the Australian standards?
I don't know what those standards would be. So I guess I don't know if
This is Mike Reiner. I can say yes. We have a master distributor in Australia. It's Environmental Hazard Management. The product holds BSI, British Standards Inc., BSI certifications, and we can certainly, if you leave your contact information, get you in contact with our folks directly in Australia who can better discuss, the approvals and what's available in Australia.
We answered the question to Chris. Thank you, Chris. I have a question from Air Johnson. Mr. Johnson, do you want to open your microphone? No. Well, here in the chat, Jeff.
Sorry about that. Can you hear me?
Yep.
Yes.
I was just curious. I'm I've been working with Theo out here quite a bit, and he said that you guys had some either testing or situations to where F500 has neutralized some pretty nasty acids. Can you explain, is it, because it's, I mean, I don't understand an acid being a hydrocarbon, so I understand how the micelles encapsulate hydrocarbons, but how does it neutralize acids?
Well, it's a good question, Earl.
I thought so.
Yeah, as far as the how, I mean, that's.
Well, let me also address this because we have Hernan Dominguez, who's currently in Argentina. He worked with all the companies in Chile who are purchasing on a regular basis the encapsulator agent to work with and neutralize the acids. So we're actually changing the pH of the acids from a 2, which leads to one classification of handling and disposal, to a pH of 6.5, which puts it in a totally different classification. And I might add a much more economical classification for handling and disposal of the acids. I think it's a misnomer. You know, we discussed that we encapsulate carbon and hydrocarbon materials, and I agree with you, acid is not a hydrocarbon material. We encapsulate a whole variety of items. For example, we have done testing through smoke flumes off of coal burning plants, and one of the applications of our product is for scrubbing within smokestacks, and in that area we're encapsulating SO2, which is sulfur dioxide, SO4, and NOx, and none of those are considered carbon and hydrocarbons. So when we say we're encapsulating carbon and hydrocarbons, it's because that's what we're usually dealing with in the fire service. But I know Hernan has created an entire PowerPoint presentation on some of the work that they've done with the gold mining people over there in Chile. And fortunately for us, he will be flying from Argentina to the USA on Sunday and back here in the USA, where we can take advantage of his full experience. So I hope that may have answered the question.
Oh, okay, so well, it kind of did. I mean, like I said, I've already kind of known that it is effective in doing that, but is it through the encapsulation process or some other mechanical action within F500? And then just to kick this out one step further, a lot of the fire departments we deal with have a concern about water treatment plants and then ammonia, and then encapsulating. They know that if there's an ammonia cloud, they can knock it down with water. But will F500, for lack of better terms, encapsulate the ammonia and to make the atmosphere even safer versus just knocking it down? And now you have, you know, ammonia in the water on the ground, or will it do something? I mean, just, do you know? Yeah,
and we don't have a clear answer on that because we've never really tested the ammonia. We have one case that happened in Arizona at Arizona Public Service where they had an ammonia leak, and according to their emergency response people, they utilized the F500, sprayed it through the ammonia cloud, and got no more ammonia readings. Now, whether that's because it was dispersed with the water or because it was encapsulated, we don't know. We really weren't given the luxury of getting all kinds of additional details on that project. They just said it worked effectively, and they built a second cart that had an elevated master stream monitor for that specific application. That's what we know at this point from ammonia. If we could maybe get Theo to go chat with Mr. Dave Kirk, we might be able to get some additional information.
Okay, thank you.
How you have to attack, because you explained somebody, I read in one part of on the chat that somebody tried to understand how you have to attack a three-dimensional fire with water and with dry powder, and how you can attack with the 500. How is the tactic of this kind of a distillation column? An example.
Well, as we were watching with the videos, when you're sitting there and you're using your dual agents, the dual agents are, you're using your water or your foams. Your foams, again, being used for fires are not designed for, to try to get some cooling. And then they're using the purple K or the powder to try to basically smother or blow the flames out, and hopefully that the cooling effect that they're using with the water or the foam is enough to cool down that distillation column enough so that they don't have a reignition. If it's not effective, it's going to have a reignition, and they can be there for hours and hours trying to extinguish the fire using those dual agents. Where when we looked at the video of F500, the encapsulator agent, we saw with that blowtorch on the hood, that rapid cooling. We saw that the ability of the agent to encapsulate fuels with the 7.7 test. So we're actually being able to do multiple things when we're being used on those three-dimensional fires. My tactics are is like with that inclined plank. When he was trying to spray directly at that incline, he was having some effect, but he was having difficulties as far as trying to get around to the flames that were on the back side of that plank. But when he got himself moved around and he was to the side of that inclined plank, he was able to have a real quick knockdown and a much better effect. So a lot of it's going to be, one, your position and how you're able to attack the fire and get the I guess the greatest possible encapsulation and cooling effect. And the other thing is your fog, your basically your water pattern. You know, are you going to use a tighter fog, a straight stream, a wide fog? So the two things that I'm going to say is being able to get yourself in your best position, because unlike foam, an encapsulator agent isn't going to create a blanket and go around obstacles. So you have to be able to you know, get your encapsulator, your water stream to be able to have an effect on extinguishing it. So it's going to be your positioning and your water pattern are the two main things when you're using an encapsulator agent.
Thank you, Jeff. I don't know if somebody want to make another question to Jeff. I have a question, Jeff, for you. All the time I have a question. When you fly and you work with the people in Vietnam, what was the reaction of the firefighter when they work with foam and when they can extinguish the truck with only one hose and A500? The fire chief of Vietnam.
You know, again, they were greatly impressed. They've made a lot of changes within their national fire service in converting to encapsulator agent F500. I mean, they've seen the benefits. And again, we have a real good distributor that's over there that, you know, he's getting in and working with the power industry with under turbine transformers and lube oil and many of the aspects. But when they sat there and they started to see the hours and the time and the amount of product that it would take to try to extinguish that tank truck, and then versus, you know, using the F500 where, you know, they're having little to no effect with foam, here they were able to totally extinguish and pretty much just walk away, or I should say walk up and touch the tank because it had cooled it to the point where, I mean, it was basically the same temperature as the water they were using.
Yes, I know your experience because you have other experience with discussing a ship with the Vietnam fire service. But this is why I try to, that you can share with all of us the expression of the fire chief when they want to touch. So we don't believe that
Yeah, well, yeah,
they are cooling the metal.
yeah. And when, you bring up the degassing of the ship, I mean, here we had, an emergency response where, a ship's hull had been filled with gasoline, and they got the gas pumped out, but they had, thousands of gallons of residual gas that was still in the bilge area of the ship. The ship's owners and the government thought it was going to take months, possibly years, to get this ship cleaned to where it could be used again. So our distributor was in contact, and they had me come over so that I could assist them, because they really weren't sure how or what tactics they should use. And again, I was called over to assist them, and we had the ship basically cleaned and degassed within 3 days.
And we have other experience about a truck on fire in Nigeria. That is a good experience of our distributor there, because the fire department use a lot of water, a lot of foam, and they call our distributor, and when he arrived with A500, they can extinguish, I don't remember, but in minutes, the fire, and they take our distributor and they put on the shout, all the people very happy because they extinguish the fire very fast. And it's in the same case like you test in Vietnam with a truck in three-dimensional fire, that the fire service use a lot of foam, try to cool it with water, but when they receive this help with this new technology, this encapsulator technology, they can encapsulate the vapor and they can cooling the metal, and they can work very fast in this fire. I don't know if you remember the minutes, or Mike.
Yes. So what it was a fully loaded tanker truck that with diesel fuel that caught on fire, and the Federal Fire Service showed up. They were familiar with F500, had a presentation, but at that point had not purchased any of the agent. So they were applying foam, and they couldn't get this extinguished. Well, the issue was it's a three-dimensional type fuel fire, and foam's not good for that. So they contacted our distributor. He was about 45 minutes. He showed up with 6 pails of F500 encapsulator agent on the job site. They were still applying foam. So now they had been applying foam for a little over an hour. And you can imagine the amount of foam that was being used. They actually took 1 5-gallon pail, poured it into their booster tank, and extinguished the entire scene and got the scene safe in a matter of about 4 minutes. And it was at that point that the Federal Fire Service said, wait a minute. Our initial impression was the F500 encapsulator agent is more expensive than the foam, but we've been putting foam down for an hour, and we've been putting down large quantities of foam, and you come out here and with 1 5-gallon pail totally extinguish this scene. So since then, they've been converting the whole entire Federal Fire Service in the country over to encapsulator technology. They were looking at, geez, I can buy foam for $25 a gallon and your product's $30 a gallon. But when they looked at, we put down 200 gallons of foam and we only use 5 gallons of yours. The foam didn't do the job and you did. Now they're going, geez, that $5 a gallon, we're looking at it the wrong way. So that was the situation there. In fact, I spoke with Nigeria today, and they just placed another nice order for the Federal Fire Service for more F-500.
Yeah, thank you, Mike, for your memory.
You're welcome.
Yeah, I remember the game, but I don't remember the minutes. This is why we need you in this webinar. Thank you so much.
Well, again, like I said, I appreciate you taking your time out of your day to spend with us and allow us to do this webinar with you. If it's something that, as I've said with my others, it's something that we can offer. If you're a distributor or you're in another country, and we can help you out with doing webinars. I mean, by all means, contact us, get a hold of Hernan. The biggest thing that I can say about Encapsulator Agent is we need to educate people. I've had many discussions when, Hernan and I were first starting out, and I've always told them, here in some of our larger countries where we have, infrastructure and we have fire hydrants and water supply and roads, it seems like, hey, if we have a major fire, we just get a bigger truck that holds more water and we can solve that problem. And when they have that bigger fire, they find out that it doesn't do the job. But when you go to Vietnam and you go to some of these other countries where they don't have a lot of water and they need to make a little water go a long way, it seems like, we're having, better acceptance in these areas, and they're finding out that it's very effective. And that's how we've been used on acid. And that's how we've been used on other instances because, hey, they're looking for a solution that doesn't take, massive quantities of water. Because of many areas of the world are experiencing drought conditions while others are getting too much rain. So whatever we can do to help, by all means, you can see on the contact us, the info at HCT-World. By all means, if training, consulting, whatever we can do to assist and help, let us know. We're here to help you out. Thank you and have a great night.